Hey, third grade, happy Monday. It's Miss Fifield here. I'm going to work with you on week 8, day 1 of your packet. So grab your packet if you don't already have it. And if you don't have your packet, that's okay, because really all you need is a pencil and paper. Okay? So first up is our fluency. Complete the chart by answering true or false. This column says attribute. So an attribute just means something that describes that figure. So the example is 3 sides. Then they show you the polygon or the shape, which we know is a triangle. So is this attribute 3 sides true? Yes, it is. So we write true. 4 sides. Here's the polygon. 1, 2, 3, 4. Is that true? Does it have 4 sides? Yes, it does. I'm going to do T for true. 2 sets of parallel lines. Now, there's a little table at the bottom to help you with some of these newer terms. So parallel lines, let me see right here, the definition: 2 lines that remain the same distance apart at all times and never intersect or touch. There's different examples here. They can be going straight up and down, diagonally, they can be different lengths, they can be going whichever way as long as they're both going the same way. So like this, like this. If they were like this, they might not be touching yet, but if they kept going, they would touch. So parallel lines are exactly the same space apart, no matter where you look at them. So does this polygon have 2 sets of parallel lines? Are these 2 parallel? And are these 2 parallel? Yes. This is called a parallelogram because it has 2 sets. It has these ones and these ones are both parallel sets of lines. 4 right angles for this last figure. Right angles we see is also defined down here. An angle that measures 90 degrees. A right angle looks like the corner of a piece of paper. So there's all these different examples, and you see that little, they make it into a box. If it makes a perfect square, it's a right angle. Do you see angles that look like that here? No, these are too small, these ones, and these are way too big. So if that is not true, we put an F for false. Okay, new learning example 1. These 2 shapes both show 3/4 shaded. So there's 1, 2, 3, 4 triangles. They're all the exact same size. They have to be, right? And 3 of them are shaded. Over here, same idea, 3 out of 4 triangles shaded, but they're laid out in a little bit of a different way. So this little speech bubble here says, I can see that both shapes are made up of triangles, but the size of the triangles is different in each shape. A triangle from this shape is much bigger than a triangle from this shape. A, are the shaded areas equivalent? Why or why not? No, the shaded areas are not equivalent. Both shapes have 3 shaded triangles, but the size of the triangles in each shape is different. That means the shaded areas cannot be equivalent. Draw 2 different representations of 3/4 that are equivalent. So when you look here, 3 out of 4 rectangles are shaded, right? If you look at this piece and this piece, they've lined it up really nice, so we can see that those are the exact same size. These figures are equivalent because the shaded pieces and unshaded pieces, all of the pieces are the same size. All right, let's try one together. These 2 shapes both show 4/5. Okay, are the shapes equivalent? Why or why not? Remember, in order to be equivalent, they have to be the same. Each piece has to be the same size. Is 1 piece from here the same as 1 piece from here? No. So here you can write, no, they are not equivalent because these pieces are just, they're not the same size. You can type that here. No, the pieces, oops, these shapes oh my goodness, what hard I'm spelling today. Oh yeah, because the okay. B, draw two different representations of 4/5 that are equivalent. So something really nice about being able to do this on my computer is that I can use a lot of different tools here. So I'm going to use a tool so that I can make sure my shapes are just about the same size. So 4/5. Now I can take that exact same piece and I can just make copies of it. Obviously you can't do that on your paper with a pencil because it's just not going to work out as exactly, but you can just do the best that you can. So I'm going to go 1, 2, 3. Oopsie. Grab the wrong thing. 4. 5. Okay, and then I need to shade 4 of them. So let me get my shading tool out. 4. 4 to 5. Now my other figure, I have to use the exact same size, okay? It has to be laid out a little differently. So we know it's still the same size, and I'm going to put it right below so you can see. Man, I did it again. One, 2. If you get bored of watching me struggle, you can always skip ahead to when I'm done. Good. Okay, but I just want to make sure you guys can see. Let's do a different color there. Blue. 1, 2, 3, 4. So both figures have the exact same size pieces. They both have 4/5 shaded. It's really just laid out differently, okay? They are equivalent. Okay, new learning. Example number 2 in your packet. Brian walks 2/4 miles down the street. Wilson walks 2/4 miles around the block. Who walked more? Explain your thinking. So when I look at the picture, I see Brian walked just like in a straight line. Wilson's is a square, but I know that I'm talking about that distance around. So from here to here to here to here is what I'm looking at. This speech bubble here says, I can see that these shapes are different, but I need to think about the units. They both walk 2/4 mile, and since the units are miles and the fractions are the same, the fractions are equivalent. So your answer is written out already for you down here. They both walked the same amount because the units are the same. They both walked 2/4 miles, even though they walked in different ways. Brian walked in a straight line, and Wilson walked in a rectangular shape. The shapes look different, but they are the same distance, 2/4 miles. So if your unit is given to you, such as miles, then we know if it's the same distance in units, then obviously that's an equivalent fraction, right? It's equal. All right, let's try one together. Diana ran a 1/4 mile Ooh, how far is a quarter mile? When we hear quarter mile, we know we're talking about 1/4 or 1/4. So I'm gonna write that up here at the top. She ran 1/4 mile straight down the street. Becky ran a quarter mile on a track. Who ran more? Explain your thinking. So Diana went outside. She just ran in a straight line down the street. Becky went to a track. Usually like the tracks go around like a field. You see them at like a lot of the middle and high schools. You might have seen them before. Maybe like at Lincoln and Bell, they have a track outside around a field. I think. So they both ran 1/4 mile, but one is in a straight line and one is kind of like in a circle or an oval. Who ran more? If the unit is the same, we're talking about a mile, and they both ran a quarter mile, which we already said is 1/4 mile. These two girls ran the same. So we can say both girls ran the same distance. Unit, miles. And worth. So I said here, both girls ran the same distance. The unit, miles, is the same for both girls, and the distance, 1/4 of a mile, is equivalent. All right. Problem set. Label what fraction of each shape is shaded, then circle the fractions that are equal. So the first thing that we can notice here is that all of the pieces here are the same size. So we don't know if there's the same amount and if they're the same amount are shaded in each, but we see each piece is the same size, which is the most important thing to notice right away. All right, so this has 1, 2, 3, 4 shaded parts. So it's 4. And then how many parts in all? 1, 2, 3, 4, 5, 6, 7, 8. Okay, first piece, 4/8. Next, 1, 2, 3, 4 pieces shaded. Got it. 1, 2, 3, 4, 5, 6, 7, 8. Great. Okay. And then 1, 2, 3 parts shaded. Out of 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4 parts shaded. Out of 1, 2, 3, 4, 5, 6, 7, 8. Okay. Since all the pieces are the same, anything that has the same amount shaded, we're going to circle. See 4/8, 4/8, and 4/8. So we can circle all 3. Oh, excuse me. All right, so we circle that one, this one, and this one. And I know you're doing a better job circling than I am. Okay. Okay. I see these are long, skinny rectangles, and they look like they're the same size throughout. So same thing, okay? We have 1, 2 pieces shaded out of 1, 2, 3, 4, 5. Okay, 2/5. Over here, I see 1 piece shaded out of 1, 2, 3, 4, 5, 1/5. Okay, 1, 2, oops, 1, 2 shaded out of 2, 3, 4, 5, 2/5 again. Cool. And last one, 1, 2 out of 1, 2, 3, 4, 5. Okay. Same thing. Go ahead and circle all the ones that are the same, all the 2/5. Ooh. There we go. Okay. This says 2A. There's not a 2B. So it looks like there should be, there's not. Label the shaded fraction, draw two different representations of the same fractional amount. Okay. You might need more space than that. Let me move this. Okay, label. So the first thing we need to do is draw two different representations of the same fractional amount. So we need to draw little rectangles that are like that same size. Each little piece needs to be, that's probably pretty close. Okay, so here's my little piece. All right, now let's go. We'll do like stacked up and down. You can do different ways than me if you think of different ways, as long as the pieces are the same. Okay, so we've got our 4 pieces, and then I just need to shade 1/4. Okay, so there's another one for 1/4. And then I'm gonna, oh my goodness, I'm gonna do the same thing over here. This time, I think I've already got a straight line here, got them stacked here, so I think I'll do an array of 2 and 2. And you can definitely do something different if you want to get a little more creative. Feel free. Okay, and I need to also shade one part. Let's go purple again. Okay, and the first part of the directions I forgot to do. It said to label, so make sure you label this fraction as 1/4. Okay. All right, next up, this back so you can see a little better. Laura has 2 different beakers that hold exactly 1 liter. She pours 1/2 liter of blue liquid into beaker A. So here's beaker A. Here. A little bit hard to see. I can relabel that here because this is A and this is B. Okay, beaker A, beaker B. You obviously also have this in your packet if you have the packet in front of you, but if you don't, this might be helpful just to kind of see it. A and B, since that's covered. Okay. Laura has 2 different beakers that hold exactly 1 liter. She pours 1/2 of the blue liquid into beaker A, and she pours 1/2 liter of orange liquid into beaker B. Susan says the amounts are not equal. Christina says they are. Explain who you think is correct and why. Okay, so it's a little bit tricky because when we look at that image, they don't look the same size, do they? Right, this one's kind of like wider and bigger, and that one's like taller and skinnier. But we know no matter what it looks like, we need to pay attention to the units. So we're talking about liters. Liters are a measurement for liquids. We talked about them a long time ago, and I always use the example. You know, my big water bottle I always bring to school every day. This is 1 liter, okay? So if there's 1/2 liter, right? 1/2, that is into container A, and that is blue, and there's a 1/2 liter of liquid from container B that is orange, even though they look different in the beakers because one beaker is wider and shorter and one beaker is taller and skinnier, it's still 1/2 of 1 liter, no matter how it looks in a beaker. If you spilled it on the floor, if you drank it, it's still a 1/2 liter, no matter where it is, and no matter what color it is, no matter what size container it's in, the amount of liquid is still the same. So Susan says they're not equal. Christina says they are equal. Who's right? Christina is correct because both containers are holding 1/2 liter of water. When the units, right, we're talking about the unit, which is the liter, units All right, let me read that back and let's see if it makes sense. Christina is correct because both containers are holding 1/2 liter of water. When the units, liters, are the same and the amount is the same, 1/2, we know that, let's say the fractions or the liters are holding an equivalent amount. That sounds a little bit better. Okay. Great job today. That is all that we have. Keep working hard. You only have 2 more weeks of distance learning, and then it'll be your summer break, so you can kind of relax a little bit. Please continue to reach out with questions. Your teachers are here for you. We want to help you as much as we can, and we hope you're working hard, staying home and staying safe, and if you need anything at all, let us know. All right, bye.